Hello YouTube, my name is Jim Neeb. This is my first YouTube video. In this one I'm going to review a new prototype laser from Opt Lasers that I've mounted to my AVID CNC router setup. If you have any questions about how to set up the software or anything for something like this, feel free to ask in the comments. Thank you. To take a little tour around the AVID CNC system I have, it's a 48 by 48 Pro system. I've got the 3 horsepower spindle on it and some extra bracing and shelving and stuff underneath. This Opt laser, I mounted a bracket for the control unit. This is nice. It has the control for the laser. It's got a nice lockout capability, and you can arm it and disarm it from here, so it's a good safety feature. So the signals from the ESS smooth stepper down in my control box down here go up to this box. It's a PWM signal plus a 24 volt input, and then the cable comes out the side here down my gantry track to the laser head. This is the laser head. You can tell it's a prototype, so some of the plastic here and the shroud down here, they're 3D printed. So I've seen pictures of the production model and they look beautiful. They're nice machined aluminum and everything. I wish I had one, but I was too impatient to wait for the production model, so I got this one. It's the same guts inside, so performance should be exactly the same. This is my air line coming in. I made my own nozzle, fabricated from one for a CO2 laser, so I fitted it in up inside here, and that really helps blow first it keeps the lens clean. No smoke can get up there because it's always blowing air out the bottom, and that really makes the cuts nice and clean, and the etching, there's no staining or smoke stains on the side like what happens if you don't have any air blowing on it. This unit can be mounted in a lot of different ways on your Z-axis. I just made a big heavy bracket to mount it to. 2 bolts come loose and it comes right off easily. Opt lasers do make quick mounts for their other laser heads. This one's a little too heavy for that quick mount. Hopefully they'll be making a heavier duty one soon for this. I don't know if they are, but hopefully they will. I'd like to get one. It makes taking the head on and off very quick, and it's also a nice safety feature because if you accidentally Z down too far or XY into something, the laser head will pop off instead of getting damaged. So it's a good safety feature to have. These laser heads aren't cheap, and you don't want to run them into something. I do want to point out that safety glasses are a must for this. I have to set my beam for testing the focus down to 0.1% of the power to not have it be too bright. So when you're cutting anything with this, if you look at the beam or the bright spot on the work surface without glasses, you can damage your eyes. At a minimum, you'll be seeing spots for quite a long time, but it's just not safe to have that thing on. That's part of the reason why they have this control box. You can lock it out so people can't accidentally turn this on. Can't really emphasize that enough. I've gotten glasses before from the Chinese laser makers. These are the ones from Opt Laser. These are much better. They're more comfortable, but they really block the blue light from these lasers as well, much better. So like I said, make sure you always have those on when you're using these. With this Z'd up high, you can see the images from the 3 different laser diodes inside this head. Laser diodes typically leave a long rectangular strip like this, so that's why they don't generally come out in a perfectly symmetrical spot without some lens tricks, because they're long and skinny like this. However, when you stack up multiples side by side, you can kind of turn it into a square, and then it does become a much better symmetrical spot. So you can see with this one, it's still not quite a square. Maybe maybe they'll have a 4 or 5 diode head sometime in the future, where you would pack in a nice array of those to make a nice square, so that, you know, when it focuses down into a very tiny spot, it's concentrated and uniform all the way across. So you can see as you Z down, the spot gets smaller and smaller, and then they start to converge into a dot. And beyond this point, you can't tell that there's 3 diodes in there when you're doing your tight focus. And then, you know, like I said, you can put in the paper and get to a smaller dot that shows up better on the camera than it does without the lens. But if you look at it through the glasses, you can see it becomes a nice small dot with that fuzziness around the edge disappearing. Also, you can see I've got a light blue piece of paper and a black piece of paper. I use these for focusing. The light blue, this is about the same color as the laser beam, and black is slightly better. Both of these kind of absorb the peripheral fuzziness from the beam. So when you look, you still have to use the glasses, even at very low power, but when you look at the beam through the glasses on these 2 colors, it will be nice and crisp, and you can really see it down to get that very fine focus that's somewhere around 5 to 7 thousandths of an inch. And if you don't use glasses and you use some other color than these, it's impossible to get it down to distinguish it at that small of a spot size. Currently engraving at about 40 inches per minute and 20% laser power. I have an air assist valve that turns the air on whenever the G-code file starts, which helps blow the smoke away, especially when cutting. It's much more efficient when the laser doesn't have to cut through the smoke. Now it's doing 100% cut runs at about 20 inches per minute, and you can see easily cuts through. Almost cuts through this 1/8 inch plywood in one pass, but it does so easily in 2 passes. The air assist makes the cut nice and clean with no smoke on the edges or the backside. Now it's going to draw a fat bar by Z'ing up 500 thousandths. It makes the beam out of focus and wide, so this is half, and then this is 600 thousandths. And the power is about 90% here. So that's the nice thing with Z control in your tool path. You can cut different kerfs easily with this laser. This is about the fattest lines before the individual spots from the 3 laser diodes start to separate in the beam, and you can see noticeable striping. So that's the one downside of a multi-diode laser head, but it's still nice. It can cut. These are over 100 thousandths of an inch wide, so it's a pretty wide cut. it helps to have a honeycomb table or something when you're cutting. It's when you see how clean these cut. When it cuts through, you don't want smoke and staining on the back side. If you lay it down on a piece of wood, the back of the project won't be clean like this. So the honeycomb lets the smoke and flame blow through without blemishing the back side of the cut. Now for software, I use VCarve primarily for designing, and a little bit with Fusion 3D for cutting stuff. But for the laser, Vectric just added a laser module to VCarve and Aspire. It's pretty good. You've used it quite a bit. You can't really do anything more with the cut and the vectoring tool than you could with just faking out a laser as a very small router bit. However, they do have the picture image toolpath that lets you upload a picture, and that is something that you really can't do with the old mechanical toolpaths. So it's pretty nice. They need to add some Z features to allow moving the head up and down to move the focal point with the surface of the workpiece, or as I demonstrated, to make the beam wider if that's desired. But hopefully they'll add that in the near future. And then I use Mach 4 as a controller, and then my CNC RouterWorks, or the AVID CNC setup, has a ESS smooth stepper. So the plugins for the ESS running in Mach 4 are working pretty well now. You do want to get the latest Mach 4 build. It's I think 4517, and the latest ESS plugin for that, which is I believe 261. Those have, especially the ESS plugins, have some required fixes for the specifically for lasering. These don't use the spindle G-code commands. They have some special macro G-code commands specifically for lasers, and the idea is you don't have to disable your spindle. You're actually using different commands between the laser head and the spindle, so you can not have to remove the hardware or disable the other controls for that. If anybody wants any help with post processors for Vectric, for the AVID CNC, or anything for this, you can let me know. I'll help you out. I spent quite a bit of time debugging it and getting the software work, so it's not too hard. But there with the post processors, Vectric changed a few things specifically for lasers, so you can't use your old processors. You have to kind of hack up your post processors to get them to work with this, but it seems to be working pretty well now. Okay, now we're going to do a demo where we do engraving of lines, which it's doing right now at 40 inches per minute and 20% power. Then we're going to do a section of engraving kind of relief work where it etches it back a ways and does a crosshatch pattern at 45 degrees to do that. That'll be at 40% power and 40 inches a minute. And then we're going to cut the whole coupon out at 100% power and 10 inches per minute, and it'll cut right through the whole piece in one pass to remove the whole logo. Now it's starting the hatch work at the first 45-degree angle. The air assist nozzle on here really helps keep the staining to a minimum and makes the cuts very clean and more efficient as well. Because the smoke actually makes the burns power of the laser beam on the smoke particles themselves, so you need to keep smoke out of the way. This air nozzle does use quite a bit of air, so my air compressor kicks in quite often. It actually doesn't need to be set up as high as I have it for air. I'll have to play with that more to see how much I can reduce it and still keep the effectiveness up. Now it's going the exact opposite degree angle for the second pass of crosshatch. VCarve Pro lets you decide if you want to just do a single pass or double pass like this, what the angle is, as well as how far apart to space the raspering lines. My laser is about 5 thousandths of an inch wide, the beam, so I'm spaced right now at 10 thousandths of an inch. After it rasters, it outlines each section that was rastered to get a nice clean edge on it. And now we're cutting through. Again, 10 inches per minute, 100% power. Now you can see the smoke is actually, and the light down below the honeycomb table, so it's blowing the smoke through this kerf and cutting all the way through. So that etched really deeply. I'm going to go blow the soot off so I can show you what it looks like when it's all cleaned up. Okay, you can see it did a really nice job. It probably went about halfway into the 1/8 inch plywood here, and again that was at only 40% power. When I was playing around with this the first time, I tried 70% power on the relief work, and it literally cut all the way through the board or the plywood, so I had to back off on the power and speed up the rate. You can also see this is still a little bit too much power for this. Is a really small font. This is only about 2/100ths of an inch tall here, you can see from the pencil mark, so that's actually too much power, and it tends to burn the wood laterally, so that's probably not a good candidate for doing that deep of an etch back. But around this edge it's very nice and clean, very deep, and then you can see the edge here cut very cleanly all the way through. So, and this, this laser works great for cutting all the way through plywood, as well as making a really deep relief carvings, and then with a 5mm wide dot can do some very fine lettering and things like that. Alright, now I'm just playing around to see what the maximum cut speed is that I can cut all the way through in one pass at 100%. I just about made it through at 20 inches per minute. So I'm trying 15 inches per minute here to see if it'll make a clean cut all the way through. Kind of looks like it is from the strength of the light that I see underneath the honeycomb table. Yep, that piece fell out, so I know it's cutting through. Now I have the smallest piece in the middle is 50 thousandths of an inch, and it cut that out. So that's about the limit is 15 inches per minute at 100% power on 125 thousandths plywood. Alright, now I'm trying to cut through 200 thousandths of an inch thick MDF with, it has a cherry ply on one side and a cheaper hardwood on the other side. So this stuff is very hard, and again it's about almost twice as thick as the previous piece that I was cutting. So I'm running at 15 inches per minute at 100% power. You can see the circle on the left there. I tried that at 3 passes. It made it through in most spots, but not quite in a couple of spots. So now I'm trying it in 4 passes. So we'll see if that does the trick. You can see under the honeycomb table that the light is starting to come through in some areas, so it is beginning to come through even on the second pass. But to get something to fall out completely, you need to get every last fiber cut. So you can see it did cut through in 4 passes, and then you can also see 3 passes almost made it through, but not quite. So that's pretty thick. Again, 200 thousandths of an inch MDF on this laser can cut through that cleanly. Okay, I'm etching my stainless steel caliper. Wanted to see what it would look like with some actual useful etching, not just some lines. %, power, 10 inches per minute on the stainless steel. Okay, that worked pretty well. It's a nice permanent etch into the metal. I can actually feel the cuts with my fingernail. And that was 10 inches per minute again, and 100% power. Okay, those engraved nicely. They have very clean lines around the edge. They have kind of an interesting raised, rough feeling to them. But they didn't take too long. Again, I was running a 45-degree crosshatch to fill those at 20 thousandths spacing. And it works pretty good that way. The beam's about 5 thousandths of an inch, so you know it leaves a pretty good gap, so it speeds up the timer quite a bit, but you don't see the gap when you do the crosshatch. It looks nice and uniform. These were just cheap blanks off of Amazon, just black slate poster blank. Etching on glass at 30% power, 30 inches per minute. I painted it black first so that it would absorb some laser energy, otherwise it just goes through the glass. And then we'll clean it off later and see if it actually etched. Okay, this is after the paint was cleaned off. I just used a little acetone to wipe it off. Again, this was 50% power. It came out about the same as the 30% power. Looks pretty good. It's etched in pretty well. You can feel it easily with your fingernail. Okay, now I'm etching a tramming tool, which is red anodized aluminum. This is 60% power, I believe, and 30 inches per minute. It's doing a great job. This is a pretty small font. It's less than a 1/4 inch tall. Yeah, that's really nice. Just hard to see with the light in here. So on pure aluminum, it just doesn't work, but anodized aluminum works great. So I rigged up this little airflow meter. It only goes up to 20 liters per minute, unfortunately, but I can dial up the airflow, and it's that's 18 there. The orifice on this nozzle that I have is about 0.2 inches, which is actually pretty big. The laser beam is significantly smaller in that part of the cone, so it could be smaller. So, you know, the airflow really needs to be relative to the size of the orifice, because that'll dictate the air velocity going through it, obviously. So on this one, you know, I'm giving you numbers for 200 thousandths, but if your air nozzle is different, you might have to play around with it and try it differently. This is, I don't know what it is, it's significantly more than 20. The sound isn't obnoxious, but you can see that this is about 7 liters per minute, and I progressively went higher and higher down to this last circle, and you can see that last one is a significantly finer cut, significantly cleaner. As far as the depth of the cut, they all are about the same. So this is about what it looks like with no airflow. So it didn't really make it cut deeper in the cut, but it really makes it cut clean without staining around the edges. You can see here, you'll see a lot of the kind of smoky edge, and you'll really get a lot of that if you don't have any airflow at all. So you really don't want to cut the plywood without some sort of air assist. And then this is probably, I'm guessing, about 20 liters per minute, or sorry, 30 or 35. That's just a guess based on the sound. I can't go higher with this meter, so I don't know for sure, but Definitely cuts significantly cleaner with that airflow. Okay, this was walnut at 4 passes. You can see it almost made it through in 4 passes. 5 passes was easy, but it didn't quite. The funny thing is, the lighter colored hard maple did cut through very cleanly in 4 passes, which is kind of strange since it seems to work better with darker materials, but maple is a wood that likes to burn pretty easily, so maybe that makes a difference. When I set the focal height on these, I focused on the top surface first to get the finest point, and then I Z'd down half the thickness of the wood because I wanted an even kerf on the bottom and top surface of the board. So these were 250 thousandths thick, or 1/4 inch. So I Z'd down about 120 or so thousandths and set my Z height there. And you can see on this maple they're nice clean cuts. The back side is clean. These smudges here are from my fingers when I got them in the soot. But again, four passes, cut through easily on both at 15 inches per minute and full power. All right, when I was in Lowe's today, I picked up one of these green ceramic tiles. It's a floor tile, 6-inch tile. Wanted to see how that would etch with the laser. As you can see, it did very well. It's definitely etched into it solidly. Kind of changed the color a little. It looks kind of cool. Almost turned it a little bit blue. This was only 1 pass at about 30 inches, 30 or 40 inches per minute, and 60% power. So multiple passes would burn deeper. But this is very permanent. It doesn't wash off. It doesn't. It changed the texture a little bit. It's really nice. So if you wanted to put custom patterns on a floor, this would work very well for that. Okay, here's kind of a final summary of some of the things I cut with this blue laser. So here's some samples of earrings. You can buy patterns for these off of Etsy pretty inexpensively. This is 1/8 inch plywood. You can see very fine detail on these. That one I got a little close to the edge. In addition, you can engrave slate very nicely. These leave a really nice little kind of sandpaper-like texture on them. You can get these off of Amazon already with the pads on them and everything. This cuts leather great. This cut right through easily in 1 pass. This is about 200 thousandths thick leather, and it also etches very nicely, so you can make nice coasters with these. A sample in wood where it's engraved pretty deeply, about halfway through this plywood, and cut it out. Some samples of thicker wood. This 1/4 inch hard, it's walnut. This is 1/4 inch cherry plywood, not really plywood, MDF. I cut through this a sheet of ABS very cleanly. Fiberglass, I was surprised how nicely it cut fiberglass cloth out. Being white and glass, I didn't think that would cut very well, but it actually cut in one pass at pretty rapid speeds. I could actually cut carbon fiber, which I was surprised. This is really heat resistant material. It did have to run at 10 inches per minute in full power, but it cut it cleanly through. So that's kind of nice. I hear that's really hard on cutters and like scissors and stuff, so being able to cut that with a laser is pretty nice. Metals, here's some examples. Stainless steel in this caliper, stainless steel washer here, I put a ring around that. Anodized aluminum etches very nicely here. Ceramic tile, this is just a standard floor tile. It didn't etch and pop the surface up. It actually melted the glaze coating a little bit and left a little texture and kind of changed the color from a dark green to blue. That's kind of a cool effect on there. And then the final thing here that worked really well is this is a full finest resolution I could do. This is about a 2.5 by 3 inch picture. It's 200 dots per inch. I ran it at the finest pitch that this laser can do, so it's about 5,000ths of an inch. So that makes it 200 dots per inch in both directions. So it's a little finer than typical newspaper print. Wood is difficult to burn for pictures because it starts out light, and as soon as you get enough power into the wood to burn it, it immediately turns black, and then it starts absorbing very well. And so it's hard to get a contrast using the programs that want to do a gradient in power. So what I did on this one was I did the design with Vectric VCarve Pro with their new laser module, and that has an option to try dithering. So with dithering, instead of varying the laser power and trying to get gradual or gradients of the darkness from changing the laser power, it uses dot density of pixels to get the dark and light effect. So it's used, in this case I was using a 10% power for the dot and then obviously 0% power for no dots. This came out extremely sharp. It also took about 6 hours for this little thing because on my CNC machine it's not set up like a CO2 laser where it scans back and forth rapidly. This has to move a lot of weight around, so it takes a long time. If you wanted to make this much bigger, you would simply defocus it and make the pixel size bigger and change your step resolution. So you could do the same resolution, not in dots per inch, but total dots across the picture, but maybe make it 20 by 20 inches. It would look the same from a distance, so that's the key there. But I was really happy with how that came out. Now I'm going to talk about a couple things that don't work well. You cannot put a mark on aluminum at all. Aluminum its absorption spectrum is below the blue laser. In fact, it's down in ultraviolet. The other thing with aluminum is it conducts heat very well. So to etch or mark or cut aluminum, you need a lot of power. A fiber, high power fiber laser could do it, but CO2, the kind of power you're going to find in a hobby laser simply won't touch it. The other things that don't cut or engrave well are acrylics, otherwise known as plexiglass. I can make marks in the plexiglass if I paint it like this, but they're not very clean and pretty. They just transmit too much light through. Even the colored ones, these are colored, but when they're cutting, you can see there's an incredible amount of dispersion of the light. I almost did cut through these in multiple passes. You can see the marks on the back. That was, I think, 4 passes on those. I think if you got some plexiglass that had a very dark pigment in it, maybe like a black, that would probably cut. You know, again, it's all about absorbing the light energy. When I ordered black plexiglass, what I received was actually this ABS, and so I didn't have an opportunity to test it out on true black plexiglass. This ABS is not the same kind of plastic, but it did cut very well. One other metal I forgot to mention was copper. I tried cutting copper or marking it with the blue laser. Copper is supposedly in the absorption area where it should absorb most of the blue laser light, but copper also conducts heat 6 times better than steel. So I think from what I could tell, it was making a very slight mark, but I think it just conducts the heat away so fast that the laser can't actually melt the metal on the surface. It works good on, again, stainless steel, steel, iron, things like that. Those absorb very well the 500 or 450 nanometer light, and they're very poor thermal conductors, so you can actually etch very nicely with 15 watts here. And again, aluminum doesn't, but anodized aluminum works very nicely. So here is a end cap from a silencer. It's solid titanium. You can see that marked very nicely. A little bit better than stainless steel even. This is a single pass with a little crosshatch pattern on it, but it's very, very visible, and you can feel the texture in that too. The other thing I forgot to point out is this little rock, little river stone. I actually etched that, and it etched into the stone very well. I think any kind of polished darkish stone like granite or darker marbles, I think would etch just fine. They tend to, basically hard materials kind of heat up and pop on the surface, so you get a little bit, it's almost like a sandblasted effect, but they etch very cleanly, and 15 watts is plenty. A blue laser seems to work very well with that. One last thing I wanted to show is that you can actually put logos on a t-shirt very nicely. This was my first attempt here. This was running at 3% power, and as you can see, it was a little bit too much power. You kind of turned it brown, and more importantly, it actually degraded the fibers in the cloth. So if I tugged on it a little bit, it started to come apart. I reduced it down to 2% power. Now it etched very nicely, and it's still very strong. You stretch it, and it comes right back. I've done a couple of different t-shirts. They seem to work much better with high percentages of cotton, rayon, and some of the plastic materials woven in with cotton on some of the blends. It tends to melt a little bit and discolor to a kind of a brownish color, so it doesn't look very good. Dark colors on cotton, you're basically burning or fading the dye a little bit, like this shows, and it stands up to the heat well and looks good. So that's something to keep in mind when you try that. So I think in summary, I'm pretty impressed and pleased with this laser. Again, this is just a prototype. They're coming out with the production versions pretty soon. They look, you know, the 3D printed plastic is gone. It's all nice machined aluminum, very sleek, and the final version does have a built-in air nozzle, which is pretty nice. In fact, at this power for cutting and stuff, it's almost a mandatory thing. It really improves the cut. I live in Phoenix, Arizona, and I was using this thing through July and August. It's rated at 95 degrees Fahrenheit. I actually was using it out in the garage here when it was 110 degrees or more several days, and I never had a problem with it overheating. The fan blows a lot of air through the heat sink. It has a pretty large heat sink back in the back. This whole section is heat sink, and it blows air through there constantly. So it's very robust. I never had any problems. The laser itself never glitched. I did have issues getting the software in Mach 4 and the plugins and stuff working. That's pretty solid now. So if anybody has any questions about that, I can give you some pointers. But I'm really impressed with the laser. It pretty much does the things I was hoping it would do as far as cutting and etching and stuff. And the ability to have this mounted to my CNC gantry, I can take this on and off in about 30 seconds. It's just 2 bolts and a quick disconnect for my air up here, and then the quick disconnect plug for all the power and communication. And then combined with the interlock safety box and control here, it's all around a really nice system. I'm really pleased with it. You can see all the victims of my testing here. I pretty much tried to cut everything I could find in my house and my garage, and it's useful for etching the metals, cutting a lot of thinner woods under about a 1/4 inch. It's more the lens focal depth that limits you to about a 1/4 inch versus the actual power of the laser. Just because the angle of the focus is too steep for doing much more depth. But you can really get a fine point on the surface for etching some really detailed work. So I'm looking forward to seeing the production version coming out. Thanks for watching. Put some comments down below if you'd like to see anything else laser related. I'm retiring later this year and plan to do more videos on other shop tools and woodworking techniques and things. So like I said, if you're interested, let me know. Thank you.